Okay, so the last topic we're going to talk about for the course is the idea of, basically you can think of it as solving systems of linear equations. And there's two methods, substitution and elimination. So I need to tell you what these words mean, what a linear equation is. We all know what an equation is. What's a linear equation? And what is a system of linear equations? So let's get going. So a linear equation is an equation where each term has, and I'll explain what this means, degree at most 1. So what does that mean? When we say it has a degree of most 1, that means two things. So each term has only one variable with the exponent being 1. Or at least can be manipulated algebraically to look like that. That will do for us. Let me give you a couple of examples and then some non-examples. So something like y equals 3x minus 4. Well, this term here, y, has one variable. It's just y. And the exponent is, of course, just a 1. If there's no exponent, it's implied to be 1. 3x, that term has exactly one variable, x, and the exponent is 1. 4 has no variables, but that's fine. We're allowed to have terms like that. So another one could be something like minus a third a plus 7b equals 12. There's another example of a linear equation. Again, the terms negative a third a and 7b have exponents 1 for their one variable. Some non-examples, some ways this can screw up. Well, if you have something like 3x squared plus 7x equals y. There's an example of a non-linear equation, since you have this term here having an exponent of 2. So that violates the definition of a linear equation. Or you could have something along the lines of 6ab minus square root 2a plus 7b equals a third, for example. Again, in that first term right here, we see a problem. Our term doesn't have one variable, it has two variables. So these guys are not linear, or these guys are. And there's nothing special about having two variables. You could have one variable, 3x minus 1 equals 7. There's a linear equation. Or it can have more than two variables. You could have something like x minus y plus z equals 1. There's another linear equation. It has three variables this time. All right, so the next thing I want to talk about is what a system of equations is. So a system of equations are a set, or is a set, I guess, is a set of equations which are all simultaneously true. So let me give you an example of what I mean. And it's more a concept. So if we have something like 2x minus 1 equals y, and let's do 3x plus 4 equals 7y, then this is a system of equations. And in fact, we call it a 2 by 2 system. So we say we have two equations, and the equations have two variables. And we'll kind of restrict our study, for the most part, to 2 by 2 equations. But just know that these techniques and these ideas can apply to any number of equations with any number of variables. For the most part, there are some hiccups. But if you are interested in this type of stuff in more generality, you want to take a course called Linear Algebra. In its essence, in some sense, is basically learning how to solve systems of equations and what that means. So what do we mean when we say we want these equations to be simultaneously true? Well, we want 2x minus 1 to equal y and 3x plus 4 to equal 7y for some values of x and y. So these values that make an equation, or a system of equations, true are called solutions. So a solution to a system of equations is an ordered pair, or it could be a triple or n-tuple or whatever, for more than two variables. Where plugging in the values into all equations in the system gives equality in each. So, for the system above, let me give you an example. So, let's check. Is, let's say 5, 9, is that? And I'm going to say, usually we do it in alphabetical order, so the ordered pair is going to be x and y. And we put our ordered pair in these round brackets to indicate it's not a set, but it's an ordered pair. So in this case, order does matter. So is 5, 9 a solution to the system above? Let's check. So remember, it has to be able to make all equations in the system true. So it was, the first one was 2x minus 1 equals y. So that is 2 times 5 minus 1. Does that equal y, which is 9? We're just plugging in x equals 5, y equals 9 into the first equation of our system. And you can see here, 10 minus 1. Does that equal 9? Well, of course, 9 equals 9. So it looks good for the first equation, but remember, it has to solve both. It has to be a solution to both equations. So let's check the second one. 3 times 5 plus 4. Does that equal 7 times 9? And you can kind of see this won't work. So this is 15 plus 4. Does this equal 63? Well, 19 doesn't equal 63. So this, unfortunately, is not equal. So 5, 9 is not a solution to the system. Well, what about, maybe I'll write solution here. What about 1, 1? So let's check this. So, again, we're going to plug in x equals 1 and y equals 1 into both equations. So the first one is 2 times 1 minus 1. Does that equal 1? Well, 2 minus 1 indeed equals 1. So we're good there. And for the second one, well, 3 times 1 plus 4. Does that equal 7 times 1? And you can see what's going to happen here. 3 plus 4. Does that equal 7? Of course it does. 7 equals 7. So 7 is indeed a solution. All right, so we know about systems of linear equations, and I just want to make a quick note that we will limit our study to systems, or let's say to 2 by 2 systems of linear equations, and maybe I'll change this will, because I probably mean we will, to 2 by 2 systems of linear equations. But again, there's nothing special about having 2 equations and 2 variables. These ideas will work for pretty much any number of equations and any number of variables, or at least you'll be able to do something with them, which is great. So there's 2 methods, and the one that I think everybody knows is substitution. So we're trying to solve equations here. Like our previous example, I just gave you some points and I said, is that a solution? But when you're actually solving equations, you're not going to get the answer and you need to check. You actually need to do something to determine what the solution is. So the 2 methods are substitution and elimination. We're going to talk about substitution first quickly because I think we all know that. So basically, what we do is we solve one equation for a variable. So that's kind of the first thing we do. And then the second thing we do is we plug that in, or let's say substitute, since we're using, we're calling it substitution, so substitute that in to the other equation. Then we solve for the remaining variable. And once we have that, we substitute that back in. And to either equation to solve for the final variable. So, it's kind of what we all do when we're solving systems of equations. And let's do one where we know the answer. So let's solve 2x minus 1 equals y, and 3x plus 4 equals 7y. I'll call this equation 1, this equation 2. Okay, so, well, we want to solve one equation for one of the variables, and we already have that in some sense. So here, in this first equation, we have y equals something in terms of the other variable. So wherever we see a y in the second equation, remember, these guys equal at the solution point, where we have a proper x and y that cause equality. And we want that point. So when we have a solution to this system, these equalities hold. So at the solution point, y equals 2x minus 1. So we can substitute that in. So let's substitute 1 into 2, okay? So we get that 3x plus 4 equals 7. And then, well, here we have that y equals 2x minus 1. So instead of putting in y, I'm going to put in 2x minus 1. Now I'm just going to solve for x. So I'm going to use my equation solving skills here. Let's clean up the right-hand side. We have 3x plus 4 equals 7 times 2x is 14x. 7 times minus 1 is minus 7. Well, let's guess, oh, I don't know. Let's get all of the variables over the right-hand side. It doesn't really matter. So I'm going to subtract 3x from both sides. That'll get rid of all the variables on the left-hand side. And let's add 7 to both sides to get rid of all of the constants on the right-hand side. I will say that if you're not sure what to do here, it is definitely worth reviewing how to solve equations. So make sure that you're good at solving equations, because if you're not, this section will be very, very hard for you. Anyway, here we go. 3x minus 3x is 0. 7 plus 4 is 11. 14x minus 3x is 11x. And minus 7 plus 7 is 0. And I expected these guys to be 0 because I subtracted 3x from both sides and added 7 to both sides expressly to get rid of those on one side. So I know that those are going to be 0. So I just have to solve this bit here. Let's divide both sides by 11 to get x by itself. 11 divided by 11 is 1. 11x divided by 11 is 1x, or just x. So I'm halfway there. I have that x equals 1. Great. Now, let's plug that in to either equation. Doesn't matter. So, let's go ahead and let's plug it into equation, maybe 1 would be easier. And I'll just tell you why I'm thinking that. So looking at it, the reason I'm plugging it into equation 1 is because, well, the coefficients are a little smaller. I think it'd be a little bit easier to calculate. You wouldn't be wrong if you plugged it into equation 2. It might be just a little more work. In this case, the difference is marginal, actually. So we have 2x, but remember, x is 1. 2x minus 1 equals y. So we have 2 times 1 is 2 minus 1 equals y. So we get 1 equals y. So we have our solution. Is, of course, 1, 1. Great. X equals 1, y equals 1. And I want to make a quick note here. It's always a good idea to check your solution. So check your solution. plugging it in to the other equation. So, in order to solve for y, we plugged it into equation 1. So let's plug our solution into equation 2. So we have 3 times x. So x is 1 plus 4. Does that equal 7 times 1? We already did this calculation, but of course we can see that 7 indeed equals 7. So when you are solving equations, you can check if you have it correct, because you can just make sure that your solution actually satisfies both equations. So we did our check, and we're happy with our answer. Let's do one more example. And I will say a lot of times that you won't end up with particularly nice numbers. In fact, your answers a lot of the times will be fractions. So you just have to deal with that, and it gets a little messy, but you can get through it. So let's solve. I'm going to just make this up. 2x plus 3y equals 7, and negative x plus 2y equals minus 3. So there we go. Here is our system. So we have to decide what variable we want to solve for. Again, let me call this equation 1 and equation 2. So my initial thought is that, well, this variable here doesn't really have a coefficient in front of it except the negative 1. So maybe I'll solve for x, because it'll be a little bit easier. But it wouldn't be wrong to solve for any of these. In fact, maybe I'll do this one in both ways. So let's solve for x in equation 2. Remember, whatever variable you solve for is going to be correct. So let's write that down. Negative x plus 2y equals minus 3. Okay. Let's get x by itself, so I'm going to subtract 2y from both sides, and I get negative x equals negative 3 minus 2y. But I want to solve for positive x, so I'm going to multiply both sides by negative 1. And remember, I have to multiply everything by negative 1. Or you could think of it as dividing by negative 1. Same thing happens. Okay. So negative x times negative 1 is, of course, x. Negative 3 times negative 1 is positive 3. And negative 2y times negative 1 is positive 2y. So we rearranged equation 1 to solve for x. So let's substitute this into the other equation, into 2. Okay. So we have 2 times x, and x in this case is 3 plus 2y plus 3y equaling 7. Okay, let's go ahead. So 2 times 3 is 6. 2 times 2y is 4y, just doing the distributive property there, of course. And we have plus 3y equals 7. All right, let's clean this up a little bit. I'll do 2 steps in one almost. I'll subtract 6 from both sides, and I'll combine these like terms in one step. So 6 minus 6 is 0. We'll do the 4y plus 3y now. That's 7y. And that equals 7 minus 6 is, of course, 1. Divide both sides by 7. And we get that y is 1/7. So this is a situation where we have a fraction as our solution. That happens quite often. There's no big issues with it. All right, so let's plug this in to either equation and solve for x. Okay, so again, let's look at our two equations. Again, it doesn't matter, but I notice that the coefficients in equation 2 just look a little smaller. It looks a little easier for me to solve for x there. So I'm going to do that. You wouldn't be wrong. Plugging it into equation 1, it would be phi. So it is negative x plus 2 times 1/7 equaling negative 3. Remember, y we have as 1/7. Okay, let's continue. So let's simplify this. We get negative x plus, well, 2 times 1/7 is the same as 2/7. Remember, we're thinking about 2 as 2 over 1 and multiplying fractions. And that equals, well, I'm going to change negative 3 to something over 7 because I know I have denominators of 7. So I'm going to multiply top and bottom by 7, and I get negative 21 over 7. And again, we're solving for x, so let's subtract 2/7 from both sides. So we get negative x plus 7th minus, plus 2/7 minus 2/7 is 0. And minus 21/7 minus 2/7 is minus 23/7, or negative 23/7. And again, let's multiply by negative 1 on both sides. And we get that x is positive 23/7. All right. And let's check this. It's always a good idea to check, make sure we didn't make a mistake. So let's plug it in to the other equation. And that equation is 2x plus 3y equals 7. So let's plug it in there. So 2 times 23 over 7 plus 3 times 1 over 7, does that equal 7? Well, 2 times 23 over 7 is 46 over 7. 3 times 1 over 7 is 3 over 7. Does that equal 7? Well, 46 plus 3 is 49 over 7. Does that equal 7? Well, 49 divided by 7 is for sure 7. So indeed 7 does equal 7. And we're happy we got the correct answer. So just quickly, I want to talk about if we did this by solving for a different variable at the start. So same thing. So try solving for a different variable. So let's solve equation 1 for, say, y. Just to show you, you'll always get the same thing. So it was 2x plus 3y equals 7. Let's solve for y. Subtract 2x from both sides. We get that 3y equals 7 minus 2x. Divide both sides by 3. And we get that 3y divided by 3 is y. 7 divided by 3 is, we can just write it as 7/3. And negative 2x divided by 3 we can write as, well, let's write it as 2/3 x. Or if you wanted to instead, you could write it as 2x over 3 instead of 2/3 x, same thing. Okay, so we solved for y. Let's sub into equation 2 now. Again, our fractions are a little harder to deal with, but that's okay. We'll always end up with the same answer. So it was negative x plus 2y, but remember y is 7/3 minus 2/3 x, and that equals minus 3. And now we just solve. So negative x plus 2 times 7/3 is 14/3, and 2 times minus 2/3 is minus 4/3, so minus 4/3 x equals minus 3. So now let's get rid of that pesky denominator of 3. So we'll multiply both sides by 3. You could keep things as fractions and just solve for x that way too. You'll get the same answer. I like to multiply through by the least common multiple of all my denominators, just to get rid of it at this stage. So negative x times 3 is negative 3x. 14/3 times 3 is 14. We can think of 3 as 3 over 1, and just multiplying fractions, your 3's will cancel. Of course, that's why I multiplied by 3. Negative 4/3 x times 3 is negative, wrong color, is negative 4x. And negative 3 times 3 is negative 9. All right, let's clean up. So negative 3x minus 4x is minus 7x plus 14 equals negative 9. Let's subtract 14 from both sides. We get that negative 7x equals negative 9 minus 14 is negative 23. And then we'll divide both sides by negative 7. So we get that. Negative 7 divided by negative 7 is 1. Of course, anything divided by itself is 1. So x equals, well, negative 23 over negative 7. A negative divided by a negative is a positive, so we get positive 23 over 7. And I'll stop there, because from there it's kind of the same thing as what we did. But just you can see that even if we solve for a different variable, it might be a little more work, but you'll always end up with the same answer. So just note that you can't go wrong no matter what variable you solve for. Even if you don't make the best choice, it'll still give you the correct answer. All right, the last bit I want to talk about, or the last method, is elimination. And unfortunately, in a 2x2 system, it works totally fine, but you don't see the power of it. So the first note I want to make is that elimination is more useful in larger systems of equations. But I just want to show you the method just to see what's going on here. And it's a really cool idea of using equality. But we'll see examples of it. We won't see the true power in a 2x2 system. So here's kind of the idea behind it. Well, let's say we have some left-hand side of the equation, A, I'll just call it all of it, I'll just call big A, and that equals some right-hand side, which I'll call big B. So maybe big A is something like 3x plus 1, and big B is like 3y, or whatever, it doesn't matter. But, so we have that, and we have a second equation in our system. Let's say big C equals big D. So remember, the golden rule of equations says that I can do anything I want, pretty much, to one side of the equation as long as I do it to everything on the other. So if I wanted to, I could add all of whatever big C is to both sides. So that's the same thing as A plus C equals B plus C. But, well, what's going on here? Well, look at this. C equals D. So maybe instead of adding C here, I'm going to change that to a D. So I get that A plus C equals B plus D. So what do? Well, we just added the left-hand sides and the right-hand sides together, and we still have equality, which is really cool. So that's kind of the idea, is we can add, or subtract, in fact, one equation to another, and still retain the same solution. Excellent stuff. So let's see this in action. You could think, well, why would I want to do this? Let me kind of show you an example why. So let's say we had the following equation. So let's have x plus 2y equals, well, let's say 4. And let's say 3x minus 2y equals negative 12. Okay. So, let's see our idea in action here. So, one thing I want to say, it's probably a good idea to make sure that your equation has all your variables on one side and all your constants on the other. So if it's not in that form, it's a good idea to kind of rearrange it to that form. It just helps keep things consistent, and it's a lot easier to add and subtract. So let's see what happens when I add, and again, let me label these. I'm going to add equations 1 and 2. So I get x plus 3x is 4x. And here's the key. This is the thing that's important. Look at this. Plus 2y minus 2y is 0y, or just 0. So I eliminated my y's here. That's what's key here. And of course, 4 minus 12 is minus 8. So I get the equation 4x equals minus 8. And now I can just solve for x by dividing both sides by 4, and I get that x is negative 2. We can just plug in to either equation, just like before, and solve for y. And I'll leave that as a little exercise for you guys, but I'll tell you what the answer is. You should get that y equals 3. So if you get that, you are good to go. But the key is that when we added these equations, we had these variables cancel for us, which is fantastic. Okay, or they are eliminated. That's why it's called elimination. So let's do another example. So let's solve the following system by elimination. So let's do, I'm going to make this up. So 2y equals 3x minus 4. And let's do x plus 4 equals y. Okay, so here's our system. Well, the first thing I want to do is get each equation into a similar form. And that form is going to be all the variables on one side and all the constants on the other. So again, I'm going to call this equation 1 and equation 2. So for equation 1, I'm going to subtract 3x from both sides. That will leave all the variables on the left-hand side and all the constants on the right. So we'll do the same thing for the second equation. Well, I will subtract y from both sides and subtract 4 from both sides as well. So getting these in the same form, well, this is 2, and I'll write it in terms, I'll put the x's first just to be consistent, so it's kind of easy to see. So I have minus 3x plus 2y equals minus 4. That's equation 1. I just rearranged it. And the second one, I'm going to get x minus y equals minus 4. Great. So you could think, well, I can't do elimination now. If I try and add or subtract these equations, then I don't eliminate any variables, so nothing works for me. But what we can do, remember, the golden rule of equations says we can multiply any equation by whatever we want, except 0, and we still retain equality as long as we do it to everything on both sides. So I can be a little bit clever here, and I can say, for equation 2, if I had a 2 here instead of a 1, then elimination would work. So what I'm going to do is I'm going to multiply everything on both sides by 2 with equation 2. So now equation 2 becomes, well, let me write equation 1 again, negative 3x plus 2y equals minus 4. And now equation 2, after we multiplied everything by 2, this becomes 2x, 2 times x is 2x, minus 2y, 2 times y is 2y, and negative 4, well, negative 4 times 2 is negative 8. And I want to point out, if I wanted to, there's nothing special about making the y's have the same coefficient. I could have tried to eliminate the x's as well, or instead, by multiplying instead by 2, I could have multiplied by 3. And that would have gave me a 3 in front of the x, and then the x's would have been eliminated. Again, either will do. It doesn't matter what you choose. Alright. So now, it looks like we can add these. So let's add 1 and 2. So, negative 3x plus 2x is 1x. Negative 3 plus 2, sorry, negative 1x, my mistake, is negative 1. We eliminated the y's, plus 2y minus 2y is 0y, and negative 4 minus 8 is negative 12. So we have negative x equals negative 12. We multiply both sides, or divide both sides, however you want to look at it, by negative 1, and we get that x equals positive 12. And once we do that one elimination step, The other steps, are, of course, are the same as before. We just plug in to either equation to solve for y, just like we did with substitution. And I will tell you, you should guess, I'll leave it as an exercise, but I'll tell you the answer. You should guess that y is 16. So if you get that, you're good to go. So our solution is 12, 16. So let's see one more example. I'll show you one more technique when it looks like you can't really do anything. You can. You can always use elimination. So let's do this one. Let's do 2x, and I'm not going to worry about rearranging the equation. So 2x minus 3y equals 6, and let's do 3x, let's do minus again, minus 5y equals 10. So you could be thinking, well, there's nothing I can multiply either equation by so that I can eliminate the variables. But if you're clever, there's a little trick that you could think of, and that is, remember, I can multiply both equations by whatever I want. So let's eliminate the x's this time. It doesn't really matter. I can multiply by the opposite coefficient. So I'm going to multiply the first equation by 3. 2 times 3 will give me 6. And I'm going to multiply the second equation by the other coefficient. So I'm going to multiply the second equation by 2. That will also give me 6. And then if I subtract, then I will eliminate my x's. That will always work for you, which is fantastic. So let's go ahead. Let's do this. So this is the same as, again, this is 1 and 2. So 2x times 3 is 6x. Minus 3y times 3 is minus 9y. And 6 times 3 is 18. Similarly, 2 times 3x is 6x. 2 times negative 5y is negative 10y. And 2 times 10 is 20. All right. So we have these equations now. Well, again, notice we have the same coefficient. Once we have the same coefficient, we can subtract these equations. So let's subtract equation 1, which is this guy, minus equation 2, which is that guy. Okay, so 6x minus 6x is, of course, 0x. That's good. The next one, we have negative 9y minus negative 10y, so that's a negative 9y. Remember, minus a negative is a plus, so negative 9y plus 10y is 1y. And 18, oh, where am I here? 18 minus 20 is negative 2. So just like that, we have that y equals negative 2. And we can plug that in to either equation to solve for x. So let's do it this time. So let's plug it into 1, I guess. Again, either one will work. So we have y equals negative 2. So we have 2x minus 3 times negative 2 equals 6. So here, well, 2x, negative 3 times negative 2 is a positive 6. That equals 6. Subtract 6 from both sides. We get 2x equals, well, 6 minus 6 is 0, and 6 minus 6 is 0. So finally, we get that x is, of course, 0. If you want to think of it, well, 2 times some number gives you 0, so that number has to be 0 by the property of 0. But we could say we'll divide both sides by 2 as well, and you'll still get x equals 0. So our solution is x equals 0, y equals minus 2. So that's great. So if you remember that little trick of just multiplying by the opposite coefficients, then you can add or subtract whatever will eliminate your variable. You'll be good to go. That will always work for you. That's a good little trick to remember. And the last thing I want to talk about is how many solutions. Well, there's 3 situations, and I'll show you all of them. We've covered only one of them so far. So the first one is kind of the most common. It's the one where there's just one solution. And we saw that in all examples so far. You do substitution, you do elimination, and you end up with the solution. We'll get to this in 2904, the next course, but the way to think about it, remember, these are called linear equations, because if you graph them in some sense, they become lines. So if you're thinking about the solution to a system of equations, well, that's where these 2 lines meet. So this here, that point, will be your solution. And the line meets at one place, so there's one solution. Again, we'll cover it in 2904, but that's kind of the geometric interpretation of what's happening. Well, the second situation is there's no solutions. And that looks like this. So here's our first line, and our second line is going to be parallel to it. So these guys never meet. Since they never meet, there's no solutions. When you're solving a system, how can you tell? Let me show you. So we'll do it via substitution, just to make things a little bit easy. No, let's do it via elimination. In fact, it'll be a one-step thing to do it via elimination. So imagine this. We have 2x minus y equals 4, and 4x minus 2y equals 7. Okay, so what I'm going to do, I'm going to multiply the top equation by 2, so we can do elimination, but look what happens. So this becomes 4x minus 2y equals 8, and 4x minus 2y equals 7. I need to subtract one equation from the other, trying to eliminate the variables. But look what happens here. This is the thing to note, is that the coefficients are the same in both equations. So there's no way to eliminate just one of them. They both get eliminated. So on my left-hand side, I have 4x minus 4x is 0, minus 2y minus a minus 2y is minus 2y plus 2y is also 0. So my left-hand side is just 0, and 8 minus 7 is 1. So I get some nonsense. So this is nonsense. So this is saying that these equations are equal exactly when 0 equals 1. And when does 0 equal 1? Never. Since 0 never equals 1, there are no solutions. All right, so that's what no solutions look like. And let's do the last one. The third scenario could be infinitely many. Solutions. And let me show you what that looks like geometrically. So again, we have some line here. But it turns out that the second equation, the second line, is just the first line, just in a different form, so that they're the same equation. And let me show you what that looks like. So let's do 2x minus y equals 4, and 4x minus 2y equals 8. Again, we'll do the same thing. Multiply the top equation by 2. So here we get, well, 4x minus 2y equals 8. 4x minus 2y equals 8. If we subtract these, we get 0 equals 0. Of course, both sides are the exact same. They're the exact same equation. So if you get something that's always true, then there are infinitely many solutions. So these equations equal when 0 equals 0. And since 0 always equals 0, these equations always equal. So there are infinitely many solutions. Any point on that one line, remember the blue line and the red line are actually the same line. They were just in different forms. Since they're the same line, well, any point on that line is going to be a solution to the system of equations. So again, if you're doing substitution, that's what you look for. If you get one of these situations where you get 0 equals something, there's no variables, you just get some nonsense. One constant equals another constant where they're actually different. If you see some nonsense, there's no solution, you're in this scenario. And if you get something that's always true, you get one constant equaling the other constant, and it's the same thing, like 0 equals 0, or 5 equals 5, or whatever, then you're in this scenario where the lines are just both the same equation. So that's it. That's all I want to talk about for substitution and elimination.